All right, here we go. Graphing a system of inequalities and checking a solution. So the first thing, you need to make sure they're both in slope-intercept form. It looks like that first one is ready to go, but the second one needs to be solved for y. So again, since this first one is solved for y already, it is ready to graph right away. The number by itself is the y-intercept, where to start on the y-axis. This is the y-axis up and down. First point will be right here on 1. Next, I look at the rate of change, the slope, which is the number in front of x, which is rise over run. First number, top number is the rise, the bottom number is the run. So it looks like from my starting point, every time I go to the right 2 boxes, I go up 1 box. Right 2, up 1. Be able to stair step both directions. The inequality tells me because it's less than or equal to, it will be a solid line through those points. Because it's less than, again, the one that looks most like a capital L, less than, I'm going to shade below. Since this is a system, I'm just going to shade a little bit until I know exactly the 1/4 of the graph where the shading areas overlap, and then I'm going to fill that in. So just a little bit below, just so I know which direction it's going. Second inequality is not solved for y. So the first thing I need to do is get rid of this 2x. The opposite is subtracting 2x. Make sure I do that on both sides of the inequality to keep it balanced. Bring down the y, bring down the more than, negative 2x minus 2. Then negative 2 is my y-intercept for this second inequality. So I'm going to go to negative 2 on the y-axis. Next, I look at my slope, the number in front of x, which is negative 2. Made into a fraction, negative 2 over 1, any whole number over 1. Bottom number tells me to go right 1. Top number tells me from there to go down 2. So here I go. Negative 2 is where I start. Right 1, down 2. Right 1, down 2. Be able to stair step both directions. So here I go in the other direction. Still on the same line. My inequality, because it's just more than without that line underneath, will be a dashed or dotted line. It is more than. Again, that does not look like an L, capital L, less than. This is y is more than. So that means the shade above. So a dotted line through the y-intercept of negative 2 and a slope of negative 2 over 1. More than means shade above. So I'm just going to shade a little bit. And then my eye tells me of the 4 parts of my graph, this is the part where the shading areas overlap. So I'm going to fill that in nice and neat. Nice, neat parallel lines. So again, I need to clearly see which 4th of your graph has that shaded area overlap. And now for the check. Any point in the shaded area will work if I plug it into both inequalities. I'm going to go for the easiest one, which is the origin at 0, 0. So 0 for x, 0 for y, the origin. If I have the choice to pick the origin for a check, usually it's your easiest bet, 0, 0. So 0 for x, 0 for y. So when I do my check, I take that first inequality I graphed. And where there's a y, I'm going to plug in 0. Where there's an x, I'm going to plug in 0. But everything stays the same. That 1/2 and the 1 are still there. So that's 0 where that y used to be. 1/2 is still there. 0 where x used to be. Plus that 1, still there. 1/2 times 0 is 0. So that gives me 0 greater than 1. And that is a true statement. Next one. Y greater than negative 2x minus 2. Again, where that y is, plug in 0. I still have that inequality more than negative 2. Where that x, I plug in 0 also, minus 2. So again, when you're doing the check, replace x and y with the point that you choose into that inequality. Remember, that first number is x, second number is y. So when I plug that in, I get 0 greater than 0. Negative 2 times 0 is 0, minus 2. 0 minus 2 is negative 2, and that check shows at that point satisfies both inequalities. Both these are true statements. 0 is less than 1. 0 is also greater than -2. Any other point in this area will give you two true statements as well. Any point along this solid line will satisfy both inequalities. Any point along this dotted line will satisfy the red line's inequality, but not the other. So you cannot pick points on this dotted line, anywhere in the shaded area or anywhere on that solid line. Fix your quiz and give it to me at the end of the period. Good luck.